First angle projection definition, symbols, conventions. What it is: first angle projection is a method of orthographic projection used mainly in Europe and Asia. Imagine you have a small model of a part placed in a first angle box. The box is turned around the model, not the model turned around the box. The view you draw is what you would see if the object were inside a glass cube and you looked through the cube from outside. Symbol: the standard symbol is a C-shaped block, a quarter circle, with a line that looks like a slice of a cylinder. It is drawn in the title block of a drawing to tell the reader that first angle rules apply. Projection planes are placed behind the object. The front view is drawn on the left side of the object's vertical plane, the top view is drawn below the front view, and the right side view is drawn on the right side of the front view. Hidden lines: dashed lines are used for features not visible from the chosen direction. Section lines: thin dashed and dotted lines show where a part is cut to reveal interior features. Orientation: all views are oriented as if you were looking at the object from the outside of the box. The front view is always upright. The top view is drawn with its upward direction, matching the front view's upward direction, etc. Real-world analogy: think of a photograph taken through a glass window looking at a toy inside a box. The picture shows the toy as if you were outside the glass. The box walls dictate where the picture appears on the paper. Why engineers use it: it lets you keep all views compactly on a sheet: the front view is in the middle, with the top view beneath it, side view to the right, making it easy to compare dimensions across views. Third angle projection is the method taught in the United States and Canada. Imagine you keep the object fixed and rotate the projection plane around it like moving a camera around a statue. The view you draw is what you would see if the object were outside a transparent box and you looked at the box from the opposite side. The standard symbol is a U-shaped block, a quarter circle, with a line that resembles a cup. It appears in the drawing's title block to indicate third angle usage. Projection planes are placed in front of the object. The front view is drawn in the center. The top view is above the front view. The right side view is to the left of the front view. Hidden lines, section lines, and center lines follow the same visual style as first angle, but their placement on the sheet is opposite. Orientation: all views are oriented as if you were looking directly at the object from each direction. The top view is drawn with its upward direction, matching the front view's upward direction. Picture a sculpture placed on a turntable. You walk around it and take photos from the front, top, and side. Each photograph is placed on the paper where you took it. The top photo goes above the front photo and the side photo goes to the left. The layout mirrors the way engineers typically think about moving a virtual camera around a model, which matches many CAD interfaces that default to third angle viewports. Basic orthographic set. Every solid part is described by at least 3 principal views: front, FR, top, TR, and right side. RS optional auxiliary views show features slanted to the principal planes. First angle layout: front view in the middle of the sheet, top view below the front view directly under it, right side view to the right of the front view. Auxiliary view, if any, is placed adjacent to the view that it is projected from, usually on the side opposite the main view. Third angle layout: front view in the middle, top view above the front view, right side view to the left of the front view. Auxiliary views follow the same rule: they are placed on the side opposite the principal view they stem from. Why the difference? Think of a page as a map. In first angle, the map is inside a box. You flip the box to see the hidden side, so the top view appears underneath. In third angle, the map shows the object outside a box, so the top appears on top. Example with a simple bracket. Step 1. Sketch the front face of the bracket, hole pattern, fillet, etc. Step 2. For first angle, draw the top view beneath the front view. The hole pattern will appear exactly under the front holes because the projection plane is behind the object. Step 3. For third angle, draw the top view above the front view. The same hole pattern appears directly above the front holes because the projection plane is in front of the object. Auxiliary view rule. If a surface is inclined 30 degrees to the front plane, you create an auxiliary projection on a plane orthogonal to that surface. In first angle, you place the auxiliary below the front view. In third angle, you place it above. Key takeaway: the relative positions of the views are mirrored between the two systems. Remember the mnemonic: first angle, bottom top, third angle, top bottom. Mathematical conversion between first angle and third angle. Coordinate system set up. Use a right-handed Cartesian system, x to the right, y up, z out of the page. For any point px, y, z in the object's 3D space, the orthographic projection onto a plane drops the coordinate perpendicular to that plane. Projection equations. Front view plane y-z, x, y, z maps to y, z. Top view plane x-y, x, y, z maps to x, y. Right side view plane x-z, x, y, z maps to x, z. First angle to third angle conversion. The geometry of the part does not change, only the sheet placement does. Mathematically, we can think of a reflection of the view about the corresponding axis. Reflection matrices. Reflect top view across the horizontal axis y. R top equals a 2 by 2 matrix with first row 1, 0, second row 0, -1. Reflect right side view across the vertical axis x. R right equals a 2 by 2 matrix with first row -1, 0, second row 0, 1. Applying these matrices to the 2D view coordinates converts a first angle drawing to a third angle drawing, or vice versa. View reversal equations practical. Top view, swap the position of the view from below to above the front view. No coordinate change needed if you keep the same orientation, only sheet placement changes. Side view, move it from right side to left side. Again, orientation stays the same. If a view has been drawn with a flipped orientation, for example top view drawn upside down, you must multiply its coordinates by the appropriate reflection matrix. Example conversion. Suppose a hole at x equals 30 millimeters, y equals 20 millimeters appears in the top view of a first angle drawing placed below the front view. To convert to third angle, keep the 30, 20 coordinates but relocate the view above the front view. No numeric change is needed because the projection itself does not invert. If the drawing mistakenly inverted the top view, mirrored left-right, apply R right to get -30, 20. Summary. Conversion is essentially a sheet-level operation. Move views according to the opposite placement rule. The underlying projection mathematics stays identical. Only optional reflections are needed if the orientation of a view was drawn incorrectly. Key formula recap. Projection onto plane P removes the coordinate n perpendicular to P. Reflection across axis A. U, v maps to plus or minus u, plus or minus v where the sign is negative for the axis being mirrored. Conversion from first angle to third angle. Apply R top to the top view if it was drawn upside down, and R right to the right side view if drawn mirrored. Otherwise, just reposition. Problem 1 - identify the projection system. Given a sheet shows a front view, a top view beneath it, and a side view to the right marked with a quarter circle C symbol. Solution: the symbol indicates first angle, the placement top view below side view right also confirms it. Problem 2 - draw the third angle multiview of a simple L bracket. Steps. Number 1, sketch the front view, the L shape on a sheet center. Number 2, locate the top view, draw it above the front view, same width, same hole spacing. Number 3, place the right side view to the left of the front view. Number 4, add hidden lines for the internal fillet using dashed lines. Number 5, insert the third angle U symbol in the title block. Problem 3 - convert a first angle drawing to third angle. Given first angle drawing of a gear with front view, top view below, and right side view right. Conversion steps. Number 1, keep all 3 views unchanged geometrically. Number 2, move the top view from below the front view to above the front view. Number 3, move the side view from the right side to the left side of the front view. Number 4, change the projection symbol from the C to the U. Number 5, verify orientations. Ensure the top view is not inverted. If it is, reflect its x coordinates, multiply by -1. Problem 4 - interpret an auxiliary view. Given an auxiliary view placed above a front view with an angled surface drawn at 45 degrees. Solution: the presence of the auxiliary view above signals a third angle system. The auxiliary view shows the true shape of the 45-degree surface. To find the true dimensions, measure directly on the auxiliary view, no foreshortening. Problem 5 - dimension extraction. Task from a third-angle multi-view of a rectangular block. Obtain the whole location. Steps. Number 1. Locate the whole center in the front view. For example, 40 mm, write 20 mm up from the lower left corner. Number 2. Confirm the same coordinates in the top view 40 mm, write 30 mm forward. Number 3. Use the two coordinates to reference the 3D position. X equals 40 mm, Y equals 20 mm, Z equals 30 mm. Number 4. Write the datum reference frame DRF accordingly. Scoring checklist used by examiners. Dash correct symbol used. Dash views placed according to system rules. Dash hidden and center lines drawn with proper line types. Dash all dimensions placed outside the view with leaders and arrows. Dash no overlapping dimensions, clear spacing. Dash auxiliary view correctly oriented and labeled. Problem-solving tip: always start by identifying the projection system symbol view layout before drawing or converting anything. That eliminates most placement errors. International Standards Comparison, ISO, ASME, BS, and Regional Usage. ISO 128-1 and 2, Worldwide Europe, Asia, Africa, First Angle Default, C-shaped quarter circle with a line. ISO 128-1:2022 General Principles, ISO 128-2:2022 Projection Methods. ISO allows both systems, but first angle is normative for most member countries. ASM EY 14.5-2021 GD&T /ASM EY 14.100-2021 Drawing, United States, Canada, Third Angle Default, U-shaped quarter circle with a line. ASM EY 14.100-2021 Unified Drawing Language. ASME explicitly states third angle as the standard for engineering drawings in North America. BS 8888:2022 Technical Product Documentation. United Kingdom, Ireland, First Angle Default, C-shaped. BS 8888:2022 Technical Product Documentation. Mirrors ISO practice. First angle is taught in UK engineering schools. Regional usage requirements. European universities and most multinational companies expect first angle drawings. When submitting designs to European clients, you must label the drawing with the C symbol and follow ISO view placement. North American firms' drawings must be third angle. Regulatory agencies, for example NASA, FAA, reference ASM EY 14.100, so the U symbol is mandatory. Global projects, often a note in the drawing header states projection: first angle ISO, also supplied in third angle on request. This avoids confusion. Inter-standard compatibility. Both ISO and ASME allow the other system to be used if clearly indicated, but the default is enforced for conformity testing. CAD packages normally store a flag for projection system. Exporting a DXF or DWG will embed the symbol in the title block, ensuring the recipient knows which convention to apply. Practical tip: when collaborating across regions, always verify the drawing's projection symbol before dimensioning. A missing or wrong symbol is a common cause of rework. A summary of differences. Symbol shape C versus U and placement order of views are the most visible differences. ISO equals first angle, ASME equals third angle, but both permit the other method when explicitly marked. The underlying geometry and dimensioning rules stay the same, only the layout on the sheet changes. Using the wrong projection symbol C versus U, students forget to look at the given symbol or assume the system based on habit. Scan the title block first. If the symbol is missing, write the correct one at the top right before drawing any view. Placing the top view on the wrong side of the front view. Confusion between first angle and third angle layout rules. After drawing the front view, ask, is the projection system first angle top view below or third angle top view above? Move the view if not matching. Mirroring a view, drawing it upside down. Misinterpretation of hidden lines or drawing the view from the opposite side of the projection plane. Check that the up direction in each view matches the front view's upward direction. Use a protractor to verify 90 degrees between adjacent views. Omitting hidden lines or using the wrong line type. Line type conventions are often overlooked under time pressure. Run a checklist. Solid lines for visible edges, dashed for hidden edges, center line long short long for symmetry. Overlapping dimensions or leaders. Crowded drawings lead to ambiguous reading. Use the no crossing rule. Dimensions must not cross other dimension lines or view outlines. Space out leaders at least 2 to 3 millimeters in the drawing. Incorrect datum reference frame DRF labeling. Students forget to state which view establishes the primary datum. Verify that the first datum is attached to a primary feature, often the front face, and is indicated with a datum feature symbol, for example, a circle with an S inside. Forgetting to show the projection method in the title block. The symbol may be placed elsewhere, causing loss of information. Ensure the title block contains drawing number, scale, projection symbol, sheet size, and revision. Dimensioning a feature that is hidden in the projected view. Without hidden lines, the dimension looks like it belongs to a visible edge. Cross-check with the other two principal views. The dimension must be visible in at least one view. Read the problem statement, note any given projection symbol. Set up the title block, write the drawing title, scale, and projection symbol. Sketch the front view. This anchors all other views. Place the top and side views according to the identified system. Add hidden, center, and section lines. Use correct line types. Dimension everything. Start with primary dimensions, then auxiliary. Keep leaders outside the view shapes. Review. Walk through the checklist above. Verify all three principal views are present. Symbol matches view placement. No duplicate or missing dimensions. All line types are correct. Datum symbols and GD and T callouts are clear. Final annotation. Write your name, date, and a short statement like projection first angle ISO verified. Clarity. Clean lines, legible lettering. Minimum 2.5 millimeters tall for dimensions. Correctness. Symbol view layout and dimension values are all correct. Completeness. All required view sections and GD and T symbols are present. Professionalism. Title block filled. Revision cloud if any changes were made. Problem-solving tip. Always start by identifying the projection system symbol view layout before drawing or converting anything. That eliminates most placement errors. Quick mnemonic for students. See below, U above. C first angle puts the top view below the front. U third angle puts it above. Explanation: impact on dimensioning, tolerancing, and GD, and across the two projection methods. Number 1. Dimension locations are unchanged. The numerical values of dimensions, length, diameter, angle, are properties of the 3D part, not of the drawing layout. Whether you use first angle or third angle, a 50mm hole will be 50 millimeters in the part. What does change is the sheet position of the dimension annotation. In first angle, a dimension that describes a feature on the top surface is written in the top view placed below the front view. In third angle, the same dimension appears in the top view placed above the front view. Number 2. Datum reference frame consistency. GD and relies on datums A, B, C that are defined on physical features. When a drawing is switched from first angle to third angle, the order of the datums, which face is datum A, B, C, does not change. It follows the engineering intent, not the view layout. However, the visual cue of which datum is primary is given by the view that shows the datum face the most clearly. In first angle, the primary datum face is often shown in the front view, center of the sheet. In third angle, the same front view is still central, but the side or top view positions may make other faces appear more prominent. Number 3. Feature control frames. The syntax of a feature control frame, for example, vertical bar diameter 20 plus or minus 0.1, vertical bar MMC, vertical bar A, vertical bar stays identical. The leader that points from the feature control frame to the feature must be drawn in the view where the feature is fully visible. If a feature is hidden in the front view, you must place the feature control frame in the side or top view where it appears. In a first angle drawing, a hidden feature that is only visible in the side view will have its feature control frame in the right-hand side view, since the side view is on the right. In third angle, the same feature control frame will be placed in the left-hand side view. Number 4. Geometric tolerances that reference multiple views. Tolerances such as perpendicularity, angularity, or position often need dimensions from two orthogonal views. For example, X direction from front view, Y direction from top view. The engineer must ensure that the pair of dimensions are on the same sheet but in their correct views. The conversion between projection systems does not alter the tolerance values. Only the placement of the references changes. Number 5. Bore tolerance example. Part A hole 30 millimeters deep, diameter 10 millimeters, position tolerance, vertical bar, diameter 10 plus or minus 0.2, vertical bar, LMC, vertical bar, A, vertical bar, B, vertical bar, where A equals front face, B equals top face. First angle layout, front view center shows datum A. Top view below shows datum B. The feature control frame is placed in the front view with a leader pointing to the hole. The datum B reference is taken from the dimension on the top view. Third angle layout, front view center still shows datum A. Top view above now contains datum B. The same feature control frame stays in the front view, but the leader to datum B must be drawn to the top view placed above. Number 6. Effect on tolerance stack-up analysis. Engineers performing a tolerance analysis use the 3D model or a coordinate measuring machine simulation, which is independent of projection method. The only practical impact is during manual inspection when a technician reads a drawing. If they mistakenly interpret a first angle drawing as third angle, they could measure from the wrong side of the part, leading to an assembly error. Number 7. Best practice. Always state the projection system in the title block. When drafting GD and add a short note near the feature control frame, viewed in front view, first angle. This reduces ambiguity for those accustomed to the other system. Use consistent datum naming across all documents, drawings, specifications, inspection reports, regardless of projection choice. Bottom line, a projection method influences where dimensions and tolerances are written on the paper, not what the numbers are. Proper labeling of the projection system ensures that the GD and information is interpreted correctly by designers, manufacturers, and inspectors. Quick tip for GD and students. Write the projection system next to each feature control frame when first drafting. You'll never forget where the leader belongs. Early drafting, late 1800s to early 1900s. The first technical drawings were hand-sketched on vellum using first angle ideas because draftsmen would place a physical object inside a glass box and look through the glass. The glass box created a mental separation between the object and its views. The first perspective scene was the one behind the object. In Europe, workshops adopted this glass box method as a standard teaching practice. American adoption of the camera view, mid-1900s. In the United States, the proliferation of photography and later of photographic projection, projectors that cast silhouettes onto a screen, encouraged a different mental model. The object stayed fixed while a camera or the projection plane moved around it. This led to what is now called third angle projection. The American Society of Mechanical Engineers, a SME, codified this approach in the 1940s in the standard ASME Y14.1, now Y14100, making third angle the default for North American industry. Standardization ISO versus ASME. ISO 128, first published in 1975, formalized the first angle method for its member countries. The standard chose the system already dominant in Europe and many Asian nations. A SME continued to champion the third angle method, embedding it in subsequent revisions of Y14.5, GD and T, and Y14100 drawing conventions. Y2 systems survived. Cultural inertia. Engineering schools taught the system they were accustomed to. Graduates carried the habit into industry. Tool compatibility. Early drafting equipment, drawing boards, parallel rulers physically supported the first angle layout, while early CAD systems in the United States were programmed to display third angle viewports. International trade. Companies realized the cost of MES interpreting a drawing was high, so both standards allowed the other system as long as the symbol was clearly marked. This flexibility enabled coexistence. The symbol's a visual story. The C symbol, quarter circle with a line, looks like a cutaway of a glass box, reminding the viewer that the object is inside the box, first angle. The U symbol resembles a cup that you can place a model outside of, hinting that the object sits outside the box, third angle. Modern trends. With global CAD platforms, SolidWorks, CATIA, Siemens and X, allowing the user to set a default projection system, the choice is now often made at the company level rather than the regional level. Some multinational firms adopt a dual system workflow. Internal designs are made in third angle for ease of use, then exported to first angle for European customers. Key takeaway for engineers. The two methods are mirror images of each other. Neither is mathematically superior. The essential rule is clarity. Always display the correct projection symbol and place views consistently with that symbol. Understanding the historical glass box versus camera analogy helps you remember which layout belongs to which system. Timeline snapshot 1880 to 1900. Hand-drafted glass box method spreads in Europe first angle. 1930 to 1940. Photographic projection influences United States drafting third angle. 1945. A SME publishes first drawing standards, adopts third angle. 1975. ISO 128 introduced, codifies first angle globally. 1990 to 2000. CAD software supports both. Symbols become mandatory. 2020 to 2026. International projects routinely include both projection layouts in the same package for interoperability.